So before we answer this question, why does the average temperature change as altitude increases? In order to answer this question, we're going to make a model of the two locations from a cross-sectional perspective. So which city is west of the other? Well, this is Mount Washington. You should be writing this down as I'm writing this down, please. And over here, this is North Conway. And what we're going to do is we're going to write their elevations. Elevation of Mount Washington is 5,200 feet, and the elevation of North Conway is 443 feet. So there's a big difference in elevation. And now we're going to think about what's going on in terms of the air. So we know from our study of the atmosphere that the atmosphere is made up of molecules of nitrogen and oxygen and carbon dioxide and water vapor. And because North Conway has a lot more atmosphere pushing down on it than Mount Washington does, the concentration of molecules is much thicker and more concentrated in North Conway than it is at Mount Washington. So down here, since they're more concentrated air molecules, why is that? Because down here at a lower elevation, we can say that North Conway has a higher air pressure. And since there's less of the atmosphere pushing down on Mount Washington, we can say that at this elevation there is a lower air pressure. So what does that mean in terms of the air itself? Well, we know that as you go up, we know that the air expands due to lower air pressure. And let's think back to the experiment that we did when we took the cans of air and we decreased the pressure inside the can. What happened to the temperature of the can? The can definitely got colder. So up here, where there's lower air pressure, if the air expands, what does it do? And that's how you're going to answer question number 5. Think back to our last meteor unit and explain what happens to air as it rises step by step. So remember our step-by-step mnemonic device to answer this question. Please use your science words.